Hi, I'm Jessica Cruz, and I'm doing Lab 3 Circuits for Physics 2212. Introduction. The purpose of this lab is to use energy and current conservation to be able to predict how circuits will behave in series or parallel when given resistors, to measure conventional current and potential difference using a multimeter, and examining ohmic resistors and capacitors behaviors. Some fundamental principles are identifying if a circuit is in parallel or series, Kirchhoff's voltage law and Kirchhoff's current law, Ohm's law, and resistance in parallel and series, how to calculate resistance. My main results are shown here for simple series circuit, and my results are also shown here for RC circuit. Systems and surrounding. The system is the circuit and the surrounding is everything else. Assumptions. The resistance of a wire and ammeter is negligible. Source of error. Rounding calculations, inaccurate ammeter reading, or inaccurate stoppage of stopwatch. Experiment for a simple series circuit. These were the initial conditions. I had 2 resistors, 2 batteries, and 2 ammeters. My results for the experimental value is 0.02A, and my actual value was 0.02A. And this is for the current. And I got that value by using Ohm's law, and for that is voltage equals current times resistance, and to get current, you just move that around, and it's resistance divided by voltage, I believe. Sorry, that's voltage divided by resistance. And if we were to put the ammeter wrong or backwards, we would read 0.02A, and that's because it depends where you put it. Like, it has to go to the positive and negative, and if you switch it, your reading becomes negative. This is our ammeter in parallel. The current was 0.02A. It now increases to 0.06A. And this was our open simple circuit. The potential difference is 3 volts, and the current is 0. Excuse me. And that's because the potential difference is 3 volts because of the battery, and the current is 0 because there is no flow of electrons. Okay, here was our simple series circuit, our graph, and our resistance values. Again, following Ohm's law, which is voltage equals current times resistance, and you just move it around, and it'll be resistance equals, I believe, voltage over current, I believe. And then here was our potential difference. This was our RC circuit experiment, and our initial conditions were the following. We had a 10 ohm bulb and a 20 ohm bulb, 1 battery, and a 200 mF capacitor. The results: the light bulb will light up and eventually become dim until it is no longer lit. This is because the current is like filling up the capacitor in a way, and then once it reaches its limit, no more current flows to the bulb, so that's why the bulb dies out. And here was our results for the charging and discharging for both bulbs. And here is our graph, which shows the slope, the predicted, and experimental. What if? What if you were doing this experiment in real life and used an actual ammeter instead of an ideal simulated ammeter? What's different about a real ammeter, and how it have affected the circuits you hooked it up to? In an ideal simulator, we do not deal with resistance or unknown forces, where in real life, ammeters have a non-zero resistance. We should then see the current in the circuit decrease. 2. What if you were doing this experiment in real life and use a real battery to charge a real capacitor with no resistor in the circuit? How quickly would our ideal model predict the capacitor to reach full charge? Would this prediction happen in real life? In our simulation, our capacitor charges instantly. However, in real life, wires have resistance, and this would cause our capacitor to take more time to charge up. Again, it's because in real life, we actually deal with resistance and like unknown variables, like our surroundings, where in a simulator, it's a perfect environment for our experiment. Thank you.